Before we get started on part 4 of this PowerPoint, I want to remind you of something we saw earlier, and that is how to know how many valence electrons an atom has, because valence electrons are the ones that do the bonding. So in this first column, they all have 1 valence electron. Second column, 2, and then if we go over here, they count like this. And then keep in mind that it's the nonmetals, and that includes hydrogen, that we're going to be talking about because those form covalent bonds. Okay, so we're ready to start writing some Lewis dot structures. And the first thing you want to do is write a skeleton. The skeleton just tells how the atoms are connected together, and you start with a dash. A dash is just one bond. So like for oxygen, we'll start with a single bond like so. Each dash represents 2 electrons. Okay, if you need to figure out what to put in the middle, like I did for this water, you put the one that's different in the middle. So like for SO2, I would put sulfur in the middle. It's different. The other thing is you could go by, these are kind of other rules of thumb, the first element in the formula goes in the middle. We call that the central atom, by the way, central atom. Or if you have a compound with 2 or more carbons, like this, the carbons will form your central atoms, will be your central atoms. That's because in organic compounds, carbon is kind of the backbone. So I'll start with carbons bonded together with a single bond, and then I'll distribute my hydrogens. For now, just kind of distribute them evenly over the 2. Okay, next we need to determine the number of valence electrons in the whole molecule. So for example, for water, well, hydrogen has 1 valence electron, and each oxygen has 6. So when we add this up, 2 times 1 plus the 6, that means I have 8 valence electrons in all of water. If you have an ion, though, you need to adjust. Remember that anions are negative and cations are positive. So if you have an anion, you're going to start with 8 electrons, but if it has a negative charge, you're going to need to add electrons to that. If it has a positive charge, you need to subtract. So for example, if we look at this polyatomic ion, hydronium, each hydrogen has 1 valence electron, each oxygen has 6. So normally I would have 3 plus 6, that's 9, but then I have a positive 1, so I need to subtract 1 to make it have a positive 1 charge. So this again would have 8 valence electrons. Okay, next we need to distribute the electrons. In other words, I'm going to start adding the rest of my electrons on there. First, I'm going to distribute to the outside or surrounding atoms and make sure they have their octet. Remember that hydrogen just needs 2 electrons, but everything else will go to 8. And then if you have any electrons over, they get left over, they go to the central atom. Okay, and if you have extras, they'll go on the central, even if it goes beyond the octet. We will see that sometimes you break that octet rule. Okay, next you need to, after you put all the electrons on, you need to maybe adjust the electrons. And that is, if the central atom does not have 8, you may need to pull some electrons from a surrounding atom to make a double bond. Okay, so, and then if you have a polyatomic ion, you need to add brackets in the charge. So let's do a complete structure for this ion. I put what's different in the middle, and then I put my other atoms surrounding, starting with single bonds. And then I see how many electrons that this would normally have, and I'll go through that again. Hydrogen would normally have 1, and oxygen normally has 6. So that would be 9. 3 times 1 plus 6, that would be 9, but I have a positive charge, so I'm going to have 1 fewer. So this needs 8 valence electrons. So I look over here at the skeleton, I say, how many electrons have I already put on there? I've put 1, 2, 3, 4, 5, 6. Each bond is 2 electrons. So I have 2 more to put on, and I check my outside atoms first, and each of these hydrogens has 2 electrons already, because those 2 count for hydrogen. They will count for oxygen as well. But anyway, each hydrogen already has 2, so I don't need to add any electrons to hydrogen. So I'll go to my central atom and add the 2 I have left, and I want to pair them up like so. And now if I check, oxygen has all of these, 1, 2, 3, 4, 5, 6, 7, 8. Because this is a polyatomic ion, I do need to put brackets around it and put its charge.